Welcome back, my dear students. This is Mr. Mahmoud explaining Algebra 2, Chapter 6, Lesson number 3, Geometric Sequences and Series. The nth term of a geometric sequence. The nth term, an, of a geometric sequence in which the first term is a1 and the common ratio is r, is given by the following formula when n is any natural number. An equals a1 r to the power of n minus 1. Let me remind you what is the geometric sequence. Geometric sequence starts with a number, let's say for example 2. Then we multiply the same number. Let's multiply 3, so it will give you 6. Multiply 3 will give you 18, and so on. In this case, the first term is 2. So we say a1 equals 2. And the number we are multiplying is 3. We are multiplying 3. So the r, the common ratio, is called 3. So in this case, an, which is the nth term that can generate any other term, is a1, which is 2, multiplied by r, which is 3 to the power of n minus 1. Such that you can find the fourth or the fifth or the sixth term. Let's try to find, for example, a5. a5 means the fifth term, so it is 2 multiplied by 3 to the power of 5 minus 1 equals 2 multiplied by 3 to the power of 4 equals 2 multiplied by 3 to the power of 4 is 81. 2 times 81 is 162. You can be sure of your answer if you keep multiplying by 3, also multiplying by 3 to reach the fifth term. So you need to remember this rule very well. An equals a1 times r to the power of n minus 1, such that a1 is the first term of the geometric sequence, r is the common ratio, the number we are multiplying to generate the geometric sequence. Find the sixth term of a geometric sequence for which a1 is -3 and r equals -2. So let's write down the formula. An equals a1 times r to the n minus 1. Replace a1 with -3, replace r with -2 to the power of 6 minus 1, because we said the sixth term. 6 minus 1 is 5, so 5, -2 to the power of 5, -32, multiply, this will give you 96. So a6, the sixth term, is 96 in this geometric sequence. What is the fifth term of a geometric sequence for which a1 is 6 and r is 2? Pause the video and try to solve, then check your answer whether it's A, B, C, or D. Now the solution. An equals a1 times r to the n minus 1. So a1, which is 6, times r, which is 2, to the n minus 1, 5 minus 1. This will be 6 times 2 to the power of 4. This will be 6 multiplied by 16, and the answer will be B, 96. Write an equation for the nth term of the geometric sequence below. Write an equation for the nth term, means find the nth term of this geometric sequence. Let's revise the information. We are multiplying by 2, multiplying by 2, multiplying by 2. If you don't recognize multiplication, you can use division using your calculator. 40 divided by 20, 20 divided by 10, 10 divided by 5. You will discover that we are multiplying by 2. So the r is 2 and 5 is the first term. Now write down the formula. an equals a1 times r to the n minus 1. Substitute a1 and r, and that's it. So an equals 5 times 2 to the n minus 1. So the equation an equals 5 times 2 to the n minus 1 is called the nth term that can generate any other term. Write an equation for the nth term for the geometric sequence below. a5 equals 4. You are not given a1, you are given a5. And r equals 3. And we need nth term. Let's try to find a1. Using the very famous formula, the nth term an equals a1 times r to the n minus 1. So we can say that an, which is a5 in this case, this is a5, which is 4, the value is 4. 5 is the order that can be put here. So 4 equals a1, which is unknown, times 3, this is the r, to the power of 5 minus 1. So now 5 minus 1 is 4, and 3 to the power of 4 will give you 81. Now divide by 81 for both sides. So a1 equals 4 over 81. Now we have a1 and we have also r, so we can write down the nth term. Let's write the equation. Again, an equals a1 times r to the n minus 1. an equals a1, which is 4 over 81 times 3 to the power of n minus 1, and we leave it as is. So the answer an equals 4 over 81 times 3 to the power of n minus 1. Write an equation for the nth term of the geometric sequence below: 3, 15, 75, 375. Try to solve and check whether your answer A, B, C or D. For this sequence, A1 is equal to 3 and R, it's clear that we are multiplying by 5, multiplying by 5, so R is 5. So now, what to choose? Very easy. It should be C. an equals 3 times 5 to the n minus 1. Write an equation for the nth term of the geometric sequence below: a4 equals 48 and r equals 2. Pause the video and try to solve. Check your answer whether A, B, C or D. Here is the solution. We know that a1 equals is unknown, but a4 equals 48, r equals 2. So the rule says an equals a1 times r to the power of n minus 1. If I can say here an is a4, this one stays a1 times r which is 2 to the power of 4 minus 1, because I mentioned here a4. Okay, what is a4? Is 48. So I can say 48 equals a1 times 2 to the power of 4 minus 1 means 2 to the power of 3 means 8. Now I should divide by 8 for both sides. This will give you a1 equals 6. Now it's clear that our choice will be this one, but let's continue to find out what's going on. So an again equals a1 times r to the n minus 1. An equals a1, which is 6, multiplied by r, which is 2 to the power of n minus 1. So A is the accurate answer. Find three geometric means geometric terms between 3.12 and 49.92. Three geometric means between these two numbers. If we are going to insert between 3.12 and 49.92, if we are going to insert three terms, so this will be a1, this is a2, a3, a4, and this will be a5 for sure. Since we are inserting three terms between two terms, so this is the first one and this will be the fifth one. So now, since there are three terms between the first and the last term, there are 3 plus 2 or 5 total terms, so n is 5. Let's find the r. An equals a1 r to the power of n minus 1. This is the formula. So we put here 49.92, and we know that this is the fifth term, so we substitute n as 5. 3.12 is the first one, a1, r to the 5 minus 1, so we can know the value of r now. Let's divide both sides by 3.12. This will give you r to the power of 4 equal to 16, so r may be positive or negative 2. You are going to take the fourth root. Now, use r to find three geometric means. There are two possible common ratios, so there are two possible sets of geometric means. Use each value of r to find three geometric means. So let's take r as 2 first. R as 2 will give you a2, means you are multiplying by 2. 3 times 12, 3.12 times 2, or 6.24. Also a3, 6.24, which is the second term multiplied by 2, then the third term multiplied by 2 to create the a2, a3, a4. The same is happening here, but we are multiplying by negative 2, so it gives you 1 in negative, 1 in positive, 1 in negative, and so on. So don't forget to use r as 2, then use r as negative 2 to create two sequences. So geometric means are 6.24, 12.48, and 24.96, or negative 6.24, 12.48, and negative 24.96. Example 3. Find three geometric means between 12 and 0.75. So as I told you, this is 12. We have a term, another term, finally 0.75. So this will be a1, a2, a3, a4, this is a5. So we all know that an equals a1 times r to the n minus 1. If we consider this one as a5, so 0.75 equals a1, which is 12, times r, which is unknown, to the power of, in this case, will be n minus 1 will be 5 minus 1. Let's divide both sides by 12. So we need to know now 0.75 divided by 12. will give you, divide by 12 for both sides, this will be 0.0625 equals r to the power of 4. Now let's take the fourth root for both sides. Of course, this should be positive or negative. So r in this case will be 0.5, positive or negative, 0.5. Let's take r as 0.5. r as 0.5, of course, we are going to have the first term multiplied by 0.5, so we'll give you 6. Multiply 0.5 again will give you 3. Multiply 0.5 again will give you 1.5. If you take r as negative 0.5, so the first one will be negative, then positive, then negative. So the accurate choice will be, yes, it's A. Now, partial sum of a geometric series. Given the sum Sn of the first n terms will be, given a1 and n, you have a1, you have the first term, and you have n, the number of terms we need to add. So we will use Sn equals a1 minus a1 r to the power of n over 1 minus r, given that r is not equal to 1. Given a1 and an will be the last term in the sum, in our sum, the last term in the sum. So the first term of the sum and the last term of the sum. So Sn will be a1 minus anr over 1 minus r. So we are going to use this one or this one according to the given in the problem. If you are given the first term and the number of terms we need to add, we will use the first rule. If you are given the first term and the last term of the series we want to add, we will use this rule. So you need to remember both. Julian sees a band at a concert. He posts a link for the band's website on his social network page. 5 of his friends repost the link. Then 5 of each of their friends repost the link, and so on. So have a pattern now. If this pattern continues, how many people reposted the link after the 6th round? Let's try to analyze the information mentioned. 5 emails are sent in the first round, and these are 6 rounds of emails. So A1, the first round, 5 posts, and each time we are multiplying by 5 for 6 rounds. It's clear that it is a geometric sequence. Now we are going to use Sn equals a1 minus a1 r to the power of n over 1 minus r, because we are given a1 and the number of terms, they are 6. Just substitute 5 minus 5 times 5 to the power of 6 over 1 minus 5. Using your calculator, you can find it as 19,530 emails or posts. So there will be 19,530 emails sent after 6 rounds. Ilani is the first one to be sent an online coupon for a 20% off sales on a retail website. She emails the coupon to 3 of her friends. They each forward the coupon to 3 of their friends. The link is forwarded again following the same pattern. How many people will receive the coupon on the 7th round of email? How many people? So she emails the coupon to 3 of her friends. So A1 equals 3. They each forward the coupon to 3 of their friends. So R equals 3. Because each one will forward the coupon into 3. So the 3 becomes 9 and the 9 becomes 27. So R multiplied by 3. Now in the 7th round means N equals 7. How many people will receive? So we need Sn. So the rule says Sn equals A1 minus A1 R to the power of N over 1 minus R. So again, A1 is 3 minus 3 times 3 to the power of 7 all over 1 minus 3. Evaluate using calculator and you will find it 3,279 people. Now, evaluate sigma from n equals 1 up to 12 means 12 terms, 3 times 2 to the n minus 1. This sign is very famous. It asks you to find the sum of the sequence or the sum of terms. So since the sum is geometric series, it's clear that it's very close to the shape A1 times R to the power of n minus 1, so it's geometric. You can use the formula Sn equals A1 times 1 minus R to the power of n over 1 minus R. This is the same formula as we were using, because naturally if you multiply A1 times the first and times the second, it will give you the same rule we are using, which is Sn equals A1 minus A1R to the n over 1 minus R. Find A1. A1, if you substitute with 1, it will give you 2 to the power of 0 means 1 multiplied by 3, 3. So A1 is 3. And it's clear that the R is 2. This is the R. So we have A1 and we have R and we have the number of terms from 1 to 12. They are 12 terms. Now we can use the rule. So A1 times 1 minus R to the power of n over 1 minus R. Just substitute with A1 as 3 and the R as 2 and the power will be 12. Evaluate using calculator. This should give you sum of the first 12 terms will be 12,285. Now model 2. Find the terms by replacing n with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. But this is a long method to follow. So the sum from n equals 1 up to 12, 3 times 2 to the n minus 1. We are going to substitute first time by 1, then by 2, by 3, by 4. Copy paste, but you are changing just the n to find the terms, 12 terms After simplifying, these are the 12 terms, 3, 6, 12, 24. It's clear that we are multiplying by 2 because really r is 2, but this is a long method. Then add them all and we'll give you the same sum we reached before, 12,285. So the sum will be 12,285. Now try to solve this problem to discover whether it's A, B, C, or D. I'll solve it right now. I'll compare this one into A1 times R to the n minus 1. So it's clear that A1 is 5 and the R is 3. From 1 to 4, we have n 4 terms. So let's use the rule Sn equals A1 times 1 minus R to the n over 1 minus R. So Sn equals 5 multiplied by 1 minus 3 to the power of 4 over 1 minus 3. Using your calculator, you will find it 200. Find A1 in a geometric series. We need A1 in a geometric series for which S8 given as 765 and n is 8, r equals 2. So let's use the formula, but we are solving equation now. We substitute Sn for its value 765. A1 is unknown, 1 minus 2 to the power of 8 over 1 minus 2. 1 minus 2 to the power of 8 will give you negative 255, divided by 1 minus 2 is negative 1. So negative will be cancelled with the negative, divided by 255 for both. This will give you A1 as 3, like solving equation for one variable. So the first term of the series is 3. By this, my dear students, we come to the end of our lesson for today. Till we meet again in another video, goodbye.